Hi students, now we are going to learn about file allocation methods. When we create a file in our system, our file is going to divide it into blocks. These blocks we call it as logical blocks. This is our file and this file has to be stored in our secondary memory. File has to be stored in our secondary memory, that is hard disk. If we are storing these blocks, that blocks will be stored and converted into physical blocks in our secondary memory. Then how these files are allocated this disk space? Hard disk means we all know the disk structure. The disk structure we call it as a platter, and we have tracks on the disk and we have some sectors. In these sectors the actual data will reside. Then this representation we are giving like this. The logical data or logic unit is converted into physical unit. Then these files are allocated some disk spaces. In these disk spaces, files are allocated. That allocation methods are of three types. They are contiguous allocation, linked allocation and indexed allocation. Then why we are going to perform these allocation methods? In order to give effective disk space utilization. In our first unit, we have discussed about CPU utilization. How we are going to utilize our CPU, which is never idle. In the same way, in order to perform effective disk space utilization, we are going to allocate this file allocation methods and to allow fast file access. In order to access a file, to do fast access, we are going to use this file allocation methods. Then we have three types of file allocation methods. What are they? Contiguous allocation, linked allocation and indexed allocation. Coming to contiguous allocation, you can see in this diagram, contiguous allocation means we have to mention, let us take, we have three files, like one is text file, second one is video file and third one is one document file. And how this data, this file is going to be stored in our hard disk. Let us take a look. We are mentioning here the starting address and the length of the file, how much space it is going to be occupied in the hard disk. You can see here the starting of text file is 0, that means it starts from 0, and the length is 3, that means 0, 1, 2 for this text file. You can see here allocated blocks. We will mention the start and length. Automatically it will allocate 3 blocks. Since it is contiguous allocation, the allocation is done in sequential order. The allocation is done in sequential order. Second one is video file, which is starting from 4. You can see here 4. And it occupies the length of 2. That means 4 and 5. Here you can see 4 and 5. Next one is document file. It is going to be start with 9 and it is occupying 3 spaces like 9, 10 and 11. In this way, contiguous allocation is done. Since it is contiguous, it will allocate the data or the physical blocks continuously. Then coming to the disadvantages of this contiguous allocation, here we can see the disadvantage of fragmentation. We all know about fragmentation, that is we have two types of fragmentations, internal and external fragmentation. Internal means the file size is, for each block if it is having 20 KB and our file size occupies only 10 KB, then the remaining 10 KB is going to be wasted. That is known as internal fragmentation. Coming to external fragmentation, according to our file sizes, we are going to allocate the memory. But if we have a file size of another 20 KB, that does not fit in this physical block, then there arises the concept of external fragmentation. We have two types, internal and external. And as the file size increases, first disadvantage is fragmentation, and second disadvantage is we cannot increase the file size since they are contiguous allocation. If the disk block is allocated to other works, we cannot increase the file size. This is one more disadvantage of contiguous allocation. Next one is linked allocation. Linked allocation is nothing but we all know about linked list, in which we can have two paths like data and pointer. Data is to reside, the actual data will reside in this data part, and the pointer is used to specify the next data or next node. In the same way, here we are going to mention the file name. The file name is zip and the starting address is 9. That means here allocation starts with 9. Allocation starts with 9. When 9 is allocated, 9 is pointing to 16. You can see here 9 is pointing to 16 and 16 is pointing to 1. 1 is pointing to 10 and then 10 is pointing to 25. And in this 25, we are placing the index as -1. That means the file allocation has been ended. When we specify negative indices, then we can tell that there is nothing reside in that location. So there is some garbage value. We have only positive indices. In this way, one physical block is going to connect with another physical block. That means here 9 contains the data and it also contains the pointer. It points to the next node, that is address of this block, that is 16. 9 will point to 16. Then 16 will point to 1. 1 will point to 10. 10 is pointing to 25. In this way, one block is connected with another block by using pointers. So there is a drawback of overhead of pointers. Here there is a drawback of overhead of pointers. In order to access this element, we need to access, or we need to start from here, then here, then here, and then at last we will reach this block. So there is overhead of pointers in order to access a particular data in a file. The next one is indexed allocation. In this indexed allocation, instead of keeping track of all the pointer values in order to access the physical blocks, we maintain only one index block. That is, here you can see file name is zip, index block only 19. This 19 will contain all the blocks of information. Like in 19, it will start from 9 to 25 and the next values are -1s. That means there is no value. Instead of having pointer values from 9 to 1, 16, like a linked allocation, in this only one block will maintain all the values. Here you can see 19 maintaining 1, 10, 9, 16 and 25. It is going to store all the values of a particular file. Wherever the file data has been stored, all the blocks will be stored in this particular index block. This index allocation is similar to our textbook. In order to read one page or read a random page, we prefer index in our textbook. Which contain page numbers. Once we refer to the index, a particular page number, we can directly open that page number and we can read that particular topic. In the same way, here it maintains one index and after opening that index we can access directly the particular physical block. In this way the indexed allocation is done. Hope you all understood all the three types of file allocation methods. What are they? Contiguous, linked allocation and indexed allocation. Thank you.